Today we're going to review lessons 1.6 through 1.9. Starting out on page 73, they have some vocabulary review. Some of this may be in these lessons, some of it may not, but we're just going to go through it all anyway. So, number one, cube root. That would be a number whose cube equals the original number. Irrational number is a number that cannot be written in the form a over b, where a and b are integers and b is not equal to 0. Product of powers property says if you multiply things with the like base, you keep the base and add the exponents. Multiply like bases, add the exponents. Perfect cube is the cube of an integer. Perfect square is a number that is the square of an integer. Power of powers property would go with the last one, but that was the one that we kind of skipped over, unless you want to remember two different things. I X'd out the wrong thing there. Oh, no, I didn't. I don't know. Power of products is one that we just altogether skipped over, so don't worry about that one either. That would be the one straight across from it. Scientific notation is a way to express a number as a product of two factors, one greater than or equal to 1 and the other a power of 10. And then square root would be a number that when multiplied by itself equals the original number. So we got kind of a spider web here, kind of a mess, but that's what that would look like. So if we go over now to page 76, lesson 6, we're just going to look at a few of these. And I'm going to skip over number 2 and 3. 3, we're not going to do anything like that with different bases. We're going to just do problems with the same base. So number 1, 6 to the 4th times 6 to the 3rd. And we're just going to write this with an exponent in our answer. So this is multiplying like bases. So we're going to add the exponents together. So you don't have to write this step, but this is what we're doing. Adding those exponents would be 6 to the 7th power. Number 4, they've written it as 4 to the 10th divided by 4 to the 4th. They could have written it as a fraction also. Those both mean the same thing. So this is dividing like bases. So dividing like bases, we're going to subtract the exponents. So 10 minus 4 would be 6. So 4 to the 6th power would be our answer for that one. We're going to do a bonus problem here that's not in your book. So they didn't do one like this, but we did do some problems like this. So 2 to the 5th to the 4th power. Remember, there was a way the book talked about it, which you're welcome to do if you want to remember two things, or there was another way we talked about doing this problem. So one way of doing this is we can say this is to the 4th power. If you take something to the 4th power, means you're multiplying it by itself 4 times. And then once we've done that, now we can use that rule. Multiplying like bases, we can add the exponents. So 5 plus 5 plus 5 plus 5 is 20. So that would be 2 to the 20th power. Okay, so again, the book does a different way, and I'm not going to mention it here, but if you do it that way, that's fine. Just realize then you have to remember, when am I adding my exponents and when am I multiplying my exponents. Lesson 7, the first part here, they want us to write these using positive exponents. So remember we talked about with positive exponents, if it's a negative exponent, we can make it positive by putting it in the opposite part of the fraction, is a way of remembering that. So first one, we got 9 to the negative 4th power. So this would be 1 over 9 to the 4th power. You can think of this as, right now, I know it's not as a fraction, but you can think of it, if you wanted to, you could put it over 1. You'd say it's in the numerator, I bring it to the denominator, and it makes it a positive exponent. Number 2, we've got 1 over 3 to the negative 5th power. So that's a negative exponent in the denominator. We bring it to the numerator, would be 3 to the 5th power. The next part, they want us to evaluate these expressions. One thing we talked about that they have here in these problems is if you have something to a 0 power is equal to 1. So first thing we can do here is we can go ahead and substitute in. So x is 2 and y is 5. And then I'm just going to give myself some room here to work. So what you can do on these problems if you want to is you can go and hunt for all of the something to the 0 powers and just say that those are going to be equal to 1. On this first part, remember we're going to do exponents before we multiply, order of operations. So I'm going to go ahead and change this 2 to the negative 2nd power. That's the same as 1 over 2 to the 2nd power, 1 over 2 squared. And I know 2 times 2 is 4. Since these are separate multiplication parts, they're separated by an addition sign. If you want to, go ahead and multiply 3 times 1 is 3. Negative 4 we can put over 1, and then we're ready to go ahead and multiply these. So if we multiply these, we're going to get negative 4/4 plus 3. Negative 4 divided by 4 is negative 1, and then negative 1 plus 3. So when we add those together, working against each other, we'd get a positive 2. So look at number 4, we've got a similar setup here. So we can go ahead and substitute again. So x is 2 and y is 5. How I'm writing this, if you want to put the exponent inside the parentheses, you can. It can be written either way. So again, if we look for these things to the 0 power first of all, so that'd be equal to 1. This part, we've got 5 to the negative 2nd power. I'm not a big fan of that negative exponent, so I'm going to rewrite that. So getting that as a positive exponent, that'd be 1 over 5 to the 2nd power. Put it in the opposite part of the fraction, makes it positive. 5 to the 2nd power, 5 times 5 is 25. And then if you want, you can put the 2 over 1, you can put the 1 over 1, and you can multiply all 3 of these together. If you don't want to do that all at once, you can multiply 2 and then multiply by the other one. But 2 times 1 is 2, times 1 is 2, 1 times 1 is 1, times 25 is 25. So 2 over 25 would be our answer for this problem. Lesson 8, we talked about scientific notation with estimating, basically. So, number 1, in the year 2013, population of California was about 38,333,521 people. Write an estimated population as a single digit times the power of 10. So what we're going to do, we're going to round to the highest place value position. We're going to round to the nearest 10 million in this case. So we're just going to look at that and think about it's between 30 million and 40 million, closer to 40 million, right? And then once we've written it as 40 million, now we're going to write it in scientific notation. So to do that, we only want one number that's not 0, then the decimal. So our decimal was at the end here. We want it to be right after that 4. So we're going to have to move 1, 2, 3, 4, 5, 6, 7 places. So this would be 4 times 10 to the 7th power. Remember, positive exponent because it's a big number. Number 2, we have a wavelength of green light is pretty small, especially in meters. What is the estimated wavelength as a single digit times the power of 10? So same idea. The first number we have that's not a 0, the greatest place value position we have is this 5. So it's just a question about whether we're going to keep that a 5 or make it a 6. Since the number after it's only a 1, we're just going to keep it a 5. And then in scientific notation. So this time we want to move this over to here after that 5. And that would move 1, 2, 3, 4, 5, 6, 7 places. This is a small number, so that's going to be a negative power. Remember, it's like dividing by 10 7 times to get back to that point. Number 3, how many times greater is the land area of Connecticut than the land area of Rhode Island? So it just depends on what we're doing here, if we're rounding these or if we're doing these exact. If we do it exact, how many times greater we would want to divide. For dividing, you can actually keep these as the same numbers that they are. And if you divide that out, you should get 4.635. They're wanting us probably to change it to scientific notation and then kind of work it out, but we really don't have to for that problem. Lesson 9, what we just looked at, writing in scientific notation. So number 1, decimals at the end, we'd like to have it after the 8. Remember, you have to write all the numbers until you get to where there's just zeros at the end. So we'd have to write 8.03 times 10 to the 8th power. We moved 8 spots. Number 2, same idea, we got to move until we get after something that's not a 0. This will be 6.8 times 10 to the negative 9th power. We moved 9 spots. It's a small number, though. It's going to be negative. Number 3, in standard form, we're just going to move our decimal 5 spots to the right. Add some zeros if we need to. So that would be 135,900. And number 4, scientific notation, we'd have to get it after the 2. Be 2.5 times 10 to the negative 11th power. We moved 11 spots. It's a small number. It's going to be a negative exponent.